Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 4 from lesson 7-7 in the Savas Realize Algebra 1 textbook. The goal of today's video is to factor out a common factor. So these examples I think of as a form of like double factoring, which doesn't make sense to you guys right now. The other thing I'm going to point out is Savas made a little bit of a boo-boo. Right here, that should be a 3. So let's go ahead and begin. So here in the top part it says, what is the factored form of this expression? So I need to factor out the greatest common factor. Now remember, when finding the greatest common factor, what we do is we break apart each term. So 3x cubed y is 3 times x times x times x times y. And 12xy cubed, 12 is the same thing as 3 times 4, and 4 is 2 times 2. So now that we have that, what we're going to do is we're going to look for the common numbers that are in both of these. So I see a 3 in each of them, so my GCF has a 3. I see an x in each of them, so it has an x. And I see a y in each of them, so it has a y. So now that I've factored that out, I'm going to take all the stuff that's left and put it back in the parentheses. So here I have an x squared. And here, notice I have a 2 times 2 and y times y. Now, looking at this, what I have so far, I have something squared minus, and really isn't this 2y squared? I mean, I could call that 4y squared and say, oh, I could factor it again, but I'm prepared to factor it again because I saw that pattern. That's following my difference of squares pattern, isn't it? Remember, the difference of squares says a squared minus b squared equals a plus b times a minus b. So what that means is that I'm not done factoring. It means I need to break up this set of parentheses into 2 sets with a plus and a minus. Now my x, which is the square root of x squared, comes here in the front, and that 2y comes here in the back. So now this is the fully factored form. Notice that I had to factor out the GCF and then factor it again. So now let's do this again. So I have 4, 24, and 36. Now looking at that, each of those is divisible by 4. They also each have an x in them. So my GCF that I'm factoring out is 4x. So 4x cubed divided by 4x is x squared. 24x squared divided by 4x is 6x. And 36x divided by 4x is 9. Now when I'm looking at this one, I see that I have the perfect square of x squared here. And I see that 9 is 3 squared. So I'm sensing that I might have a perfect square trinomial. Remember, perfect square trinomials, those factor like this. So if you have a binomial times itself, you get this pattern, a squared plus 2ab plus b squared. So what I need to do is I need to see if I take 6 and divide it by 2, if it's equal to x times 3. So 6x divided by 2 left me with 3x, which is indeed x times 3. So this is a perfect square trinomial pattern. And so what that means is that I can take this and write it as a single set of parentheses with a square here. My first sign is a plus. This x comes down and this 3 comes down. So there's my fully factored form. Alrighty, so we're going to do it just one more time. So now 50x squared and 32y squared, those are both even, aren't they? They don't have anything else in common, so I'm going to go ahead and just divide a 2 out. So when I do that, I get 25x squared minus 16y squared. And that is a perfect square a difference of 2 squares, isn't it? Because 25x squared is the same thing as 5x squared. And 16y squared is the same thing as 4y squared. So I can actually write that as 2 sets of parentheses separated by a plus and a minus. The 5x goes in the front part of each one, and the 4y goes in the back side. Now understand, guys, factoring out a GCF before you factor doesn't just work with perfect square trinomials and difference of squares. It works with any type of factoring. So when you factor a GCF out first, what it does is it makes the numbers that you're dealing with smaller and sometimes reveals additional number patterns. All right. So there we have it, guys. Until next time.